Hello, I'm Mike Elner, Northumbrian Water's Liquid Waste Treatment Manager. I'm conducting this virtual tour today where we'll be taking you through the various stages of domestic treatment works. Broadly speaking, there are two types. We have those employing trickling filters, and then with the other, which is what Bran Sands is, and that is known as an activated sludge plant. All these plants characteristically have the same treatment stages. The first one, believe it or not, is an inlet works, broadly known as preliminary treatment stage. What you can see here are large mechanical screens, and their job is important. They're actually going to screen out all the impurities that we have flushed down our toilets, down our sinks, bath, baby buds, cotton buds, toilet tissue, all sorts of debris gets removed here. It's a simple screen, and then towards the back of this plant we will have a detriter. What that's doing, that's removing all the sand, silt and tiny gravelly bits that we find are washed off our roofs, washing off our drives at home, and they are coming down through the pumping station that we have. So we're now at the end of the preliminary treatment. So once you've taken out all the rags and the degritting all those sands and silts, we move to a small pumping station. And what these do is convey this clean but still raw effluent sewage up into these very large primary tanks. And what's going to go on in here is gravity. We're not going to do anything scientific or technical. We're not going to add any chemicals. We've got covers on our primary tanks at Bran Sands, and it's here that we control odours. We are now going to hold up the effluent for about 2 hours in here. And what that's going to do, it's going to allow the sewage to separate out. So you're going to get a nice supernatant, which we call settled sewage. Then you're going to be left with a very enriched product. In the industry, we call this primary sludge. And what I'm showing you here, where we are going to convey this sewage, this is usually conveyed in large pipes like these. Of course, with Bran Sands, we're covering the whole of Middlesbrough, Thornaby, Stockton, parts of Yarm and parts of Billingham. So it's a huge urban area that's conveyed and covered. And these are the sort of sizes of the pipes, diameters used to convey that sewage to us. So after this primary stage, where I've explained separation, the sewage is left for 2 hours and it's separated nicely out. We've got a nice thick layer at the bottom, which I've said is primary sludge, and that's really good, almost crystal clear top layer, and that's the supernatant. Now, it's that supernatant that's pumped through a large pumping station like this. It's almost quite cleaned already, but the next stage is probably the one that's most interesting. This is where the biology comes in. So we're going to grow billions and billions of microorganisms on that effluent. So we're now at the secondary stage. So we've got this supernatant from the primary tanks, and that's been pumped over to here. What you're looking at is a selector zone, and you've got a constant supply of homegrown biomass, which is constantly being recycled to this selector zone and all mixed in. What you can see here is the two processes occurring at once. You've got us providing the retention time, so the effluent will be sitting here for about 4 hours in dry months, and we are also supplying oxygen because the biomass requires oxygen. All its food is already supplied by the population. That is what is within the sewage. Anything that's got carbon, sugar, proteins, lipids, fats, fatty acids, this bacteria will thrive on. What you can see here is quite a turbid oxygenation on the surface, and that foam is deliberate. It's a sign of a good, healthy, respiring and breeding biomass. And lots of surplus biomass is growing. So what you see here is literally billions and billions of free-floating bacteria. And once it's completed, our next task is to separate this out. We need to keep the biomass though. We need to remove the new growth of biomass. And then we also need to be left with a nice, clean, clear final effluent. So we're now going to move on to our final effluent settlement tanks. This is the final stage. And this stage, this is one of the most important. We now have to separate out that biomass I spoke about. So you can see we are going to do this in these carefully constructed final settlement tanks. And what you're looking at is a scraper bridge. And these tanks are constructed to be like a cone. It's almost allowing gravity to really enhance the separation. And the effluent sits here for no more than an hour and a half. And would you believe it or not, at the bottom of this tank there was a biomass blanket level. We call that a sludge blanket level, or secondary activated sludge. 2/3 of that are constantly returns to the front of the activated sludge plant. Remember I said about the selector zone? It's going to go back there. And that's now going to then kick-start the new growth. And it's constantly taken out and processed on. So what we've got here is an empty final settlement tank. And I explained about the bridge and the scrapers, and you can see just what that looks like in this empty tank. The floor comes into the middle. It's a center distribution chamber, and it calmly dissipates the energy out of the water so that it allows a very stable gravity to occur. And that's going to allow a nice clean separation. And that's what gives us this perfect clarity to our final effluent. On our plant, Bran Sands, that's typically 20 milligrams per litre suspended solids. Now this site, Bran Sands, we are on the coast. We also have a UV plant. So we've got tertiary treatment. The UV plant has got 4 channels. And there are 3 banks of 12 modules in each channel. And what they're doing is applying a green light in the UV spectrum so that all the pathogens in this final effluent product are going to have their DNA interfered with so that they can no longer reproduce. So they're going to be released back into the environment, but they can't no longer grow.